Hello everyone and welcome to another problem solving session with Special Maths Academy. So in today's video we are going to cover the first problem in the just concluded first round Nigerian Maths Olympiad 2020 senior session. And the question goes like this. For all natural numbers n, define Sn to be this. Which of the following is false for some values of n? So these are the options. So as the question is structured, we have to actually test out the options. We have to look at each option individually and check if it satisfies the property of Sn. So we just start with in chronological order. So first of all, we test the first option. So the first option says 3 divides Sn. So let's check if that is true or false. So Sn is this as you see here. So Sn is equals to 1 plus 2 2n plus 2 2n plus 1. So we have to check out this Sn mod 3. If you remember that 0, we have 3 divided 2. So we clearly know that 2 raised to power an even number, let's say 2k, is the same thing with 4 raised to power k, like normal laws of indices, and 4 is 1 mod 3, so it's equivalent to 1 mod 3. So this is just a basic observation that will help us to check if 3 divides Sn or not. So now, from this observation, we can then conclude that yeah, 1 is always 1 mod 3. Then this is 2 raised to power. 2 raised to power n is an even number for any n natural number. So based on what this observation got above, it will still be 1 mod 3, and the third term also be 1 mod 3. So this is 3 mod 3. This is 0 mod 3. So it implies that 3 divides Sn. So the first option is correct, so it's not the answer because we are looking for the option that is wrong. And then next up, we test the second option. So let's test the second option. So we want to check if 7 divides Sn or not. So this one is a little bit slightly more complicated than the first one, but it goes along the same similar line. So now since the basis of these two terms, 1 is always 1 mod any natural number, so it can't really change. It's not a function, it's just a constant. So we are more interested in what the remainders are in these last two terms. So we know that 2 raised to power 3 is 8. Yeah, and 8 is 1 mod 7. So this is just indirectly saying that the order is of 2 mod 7 is 3. So then from here, from this fact, you can conclude that 2 raised to power any natural number is equivalent to 2 raised to power that natural number mod 3, like as the power. You find the natural mod 3, you find the remainder when 3 divides the power, it's going to be equivalent to when that number is just the power. Based on this simple power, we can easily deduce why it has to be 3. So the equivalent mod 7. So from this, we now then check if this second property is true or false. So now let's do it. Remember, this is 2 raised to power n, not 2n. It's 2 raised to power. The power is 2 raised to power n. So there are 3 layers, not 2n. That's the power. So then from here, based on the facts we got said on the left hand side, we can conclude that this will be 2n mod 3 plus 2n plus 1 mod 3 also. And that's equivalent to 1 plus 2. 2 mod 3 is minus 1. So this is minus 1 raised to power n mod 3 plus 2, also minus 1 raised to power n plus 1, just as n plus 1 is there, mod 3. So now, look at the same properly now. If n is odd, one of these will be 1 and the other one will be minus 1, which you can actually change to 2, because minus 1 mod 3 is 2 mod 3. And if n is even, 1 will also be 1 and the other one will be minus 1, which you can also change to 2, because minus 1 mod 3 is equal to 2 mod 3. So regardless of n being odd or even, we just know that one of them the power will be 1 and the other one the power will be 2. Like, it's not necessarily true that the second one the power will be 1. It's only true when n is odd. But because of we did the two cases and so that it's just like they just swap. If n is odd, this one will be 1. If n is odd, the power here will be -1 and the power here will be 1. And if n is even, the power here will be -1 and power here will be 1. So just then we can easily conclude that we get these residues. So then this is 1 plus 2 plus 4. And this is 7. So it's 0 mod 7. As you can see, this is also divisible by 7. So the first and second properties are both true. Then next up, we go to the third, we check out the third property. So now we are going to the third property. As you have seen, I've created out the first two properties in order for us to still be looking at the question while we are solving it. So for the third property, it says we should check if this is true or false. So let's just check it out. Let's write Sn is what is given to us in the question. And Sn plus 1 is just like a shift. You just put n, replace n to n plus 1. That will be Sn plus 1. N plus 1 here because we are replacing n with n plus 1. So it's going to be n plus 2. Yeah. So we want to prove or disprove this. But because like this is a divisibility, we can break this down to equivalent statements. And since the statements will be getting, or the statement will be getting their equivalent, if we arrive at a last point that we see that the divisibility is true, then it means that the original divisibility was also true. And if we arrive at a point where we see that divisibility is false, it means the original divisibility was also false because they are all equivalent. So from here, we can do some basic manipulations. I'll know that like this divides this. For example, A divides B if and only if A divides B minus A. So this is what we're going to apply here. We're just going to subtract this left hand side from this because I want to clear out this one. So that is the idea of why we do that. And subtract what's on the left hand side, like the divisor. As you can see, 1 will cancel out, and also 2n plus 1 will cancel out. So we'll be left with 1 plus 2, 2n plus 2. Sorry, this is 2 raised to power n, not 2 raised to power n plus 1. This is 2 raised to power 2 raised to power n plus 2 minus 2 raised to power 2n. So this can be factorized. So you can just bring this out. These are just some lots of indices we are using now. So the power of this first term here will be, this will be what the power will be. And just write it at one corner here. So the power will be, this will be the power. So that will be 2m, 2 squared minus 1. That will be 3 times 2m. So this will put the power. I'm cleaning it out. 3 times 2 raised to power n. Then this is minus 1. So we have that this and clearly this is an odd number because the sum of an even number plus an even number plus an odd number, which odd. And this right hand side is an even number. But we have that this is like this right hand side is like a product of some kind of powers of 2 times an odd number. So because this is an odd number can never share a factor of the power of 2 because the only factors of powers of 2 are 2 and an odd number doesn't, 2 doesn't divide an odd number. So we can like, this is true. Like if this divisibility is true, it will also be true when we eliminate these powers of 2 out because you cannot share a device of the power of 2. So this will also be equivalent to trying to show that this divisibility is also true. This is just we're just rearranging this. These are just laws of indices. 3 times, like when we have 2 powers, a x y, a x y. I'll just clear it out. just like a bit together here, but just the same laws of English usually apply. So from here we have this. Now this stuff on the right hand side is of the form x cubed minus 1. And we know that this can be factorized into x minus 1, x squared plus x plus 1. So we can actually simplify this and get that you can still keep this if and only if and this equality sign, because everything we are doing can still go from back to front. So applying this identity like x cubed minus 1, applying it here, we get that this number that is to be divided is actually equals to this 2n squared. So this number squared, remember when you are squaring the number, it's the same thing as multiplying the power by 2. So what does that mean? The same thing as multiplying 2n times 2. So 2n times 2, 2 raised by n times 2, 2 raised by n plus 1. So just put 2 raised by n plus 1 here. And I'll write 2 raised by 2n plus 1. So if you notice, this and this are the same thing, and this is a whole number. So definitely this divisibility is true. So the third property is also true. And now we go to the fourth property. So we have seen that the first, second, and third property, they are all true. So as at now, we don't see no answer. The answer can either be the fourth or the fifth. So let's check out the fourth one. Yeah, so there are just a lot of digitability rules that are tested here and order and just some basic manipulation and lots of indices also. But of this question has a lot of facts that was helpful in solving it. So this fourth property now, Sn squared, is actually an inequality. It's not like a divisibility this time around. So you can just put it in and see whether this is true. So this is true if and only if 1 plus 2, 2n plus 2, 2n plus 1 squared is greater than 1 plus 2, 2n plus 1 plus 2, 2n plus 2. So let's square this. Then I'm just clean this out. So when we square this, we are going to get 1 plus, you square the second term. Remember, when you square the second term, you same as multiplying the power by 2. So like this. 1 squared third term to get this. Then we now start doing 2 times the combination of the pairwise product. But if you notice, like when I square this first term, the second term, and the third term, like we get what's on the right hand side of the inequality. And all the numbers we still get in these 2 times, the pairwise product, they are all positive. So you can easily conclude that this inequality is actually true, because this is what is on the right hand side, and you know that what will be inside here will be greater than 0, definitely. So we don't really need to actually find that. So the inequality is true. So right now, we can actually conclude that the answer is E, because this is an objective exam. But just to be rigorous, I'll show like why E. I'll find some values of n that E is actually false. But from if we're in the exam, we can just conclude now that the answer is E. Since we have shown A to D is true, but the question is asking us to find which of the properties is false. So now, for E part, we say that this is what we have to prove. So look at this structural question. Which of the following is false for some values of n? It didn't like say which of the following is false for all values of n. That is the, so this E may be true for some values, but it may be false for some other values. And we notice in the first 4 properties, I didn't like test it, put in any special number. We just did the general case and we saw that it was always true. So but in this inner, now we start plugging in some numbers, of course. That's where we get the contradiction. So first of all, let's just find the first 3 values of Sn. So S1 is 1 plus 2 raised power 4. 1 plus 2 squared plus 2 raised power 4. That is 21. Then S2 is 1 plus 2 raised power 4 plus 2 raised power 8. That is 273. And S3 is 1 plus 2 raised to the power 8 plus 2 raised to the power 16. That is 1 plus 256 plus 6, 5, 5, 3, 6. So that's 257, 9, 7, 5. Yeah, 65793. I'll just think out. 65793. So now let's test this. I'm putting a different box now. So this one I want to prove. Let's test this for n equals to 2. For n equals to 2, I want to check if this is true. 12 S1 times S2, that is less than S3. So that is if I'm putting a different marker. 12 times, what is S1? 21 times 273, that is less than 65793. Okay. So now in order to so we just a simple calculator check will make us to know that this right hand side is 68796 and this is 65793. So definitely this inequality is wrong, and it shows the reason why E is not actually always correct. So the answer to this question is option E. I really hope you enjoyed the video, and share and subscribe, and look forward to more videos to keep on adding content as soon as possible. So thank you and have a nice day.